This is number 12 from the review. On this problem, we're going to need to be very careful with our negatives, I can already tell. So here we have a series. We want to show that the series is equal to 1/2 n times 9 minus n. Again, we have the n equals 1 case. 4 equals 1/2 of 8. 4 equals 4. So our n equals 1 case works. We're going to assume k works, show k plus 1 works. So I have my if-then set up. For my then statement, I have added an additional term, this 5 minus k plus 1, and I've replaced the k's from the right side of my equation with k plus 1's. From the step above, I know that this grouping is equal to 1/2 k times 9 minus k. So I can replace this right here with 1/2 k times 9 minus k. And then I just need to bring down that k plus 1 situation, this guy right here, to my problem, plus 5 minus k plus 1. And again, I'm just working with my left side to match my right side. I'm going to need to multiply through that 1/2 k and multiply through the negative. So that's what I'm going to do as my first step on the next slide. So multiplying through the 1/2 k, I get 9/2 k minus 1/2 k squared. Multiplying through the negative, I have a positive 5, and then I have minus k minus 1. It always helps me to put my terms in order. I can also go ahead and combine some like terms here. So I'm going to go ahead and add the 5 and the negative 1 and put everything else in order. So I have negative 1/2 k squared plus 9/2 k minus 1k, which is 2 over 2 k's, plus 4. We know that our goal is to have a 1/2 on the outside. If we go back and look at our goal, here we had a 1/2 on the outside. So I'm going to go ahead and factor out that 1/2. I'm going to factor out the 1/2 actually after I combine my like terms here. So I have negative 1/2 k squared plus 7/2 k plus 4. Factoring out the 1/2, I just want a positive 1/2, not a negative 1/2, so be careful with that. Here I have negative k squared plus 7k, and then 4 divided by 1/2 is 8. And now I factor. I'll let you guys factor that, but what you should come up with is negative k plus 8 and k plus 1. So I'm going to write what I have right now, 1/2 negative k plus 8 k plus 1 is equal to what my goal was. So my goal was 1/2 k plus 1, and then I had 9 minus k plus 1. Let's see if I can get these to be the same. So the 1/2's all good. K plus 1 is good. If I switch the order here on the negative k plus 8, that gives me 8 minus k. And if you think about how this works over here with the 9 minus k plus 1, this is 9 minus k minus 1. 9 minus 1 is 8. So those are exactly the same. And our proof is complete. You always want to state at the end, remember, conditions 1 and 2 are satisfied, and therefore the statement is true.
Made with Doodlecast Pro.